A woman wrote the future and nobody listened. In 1843, she described a machine that would not exist for 100 years. She explained something her own era did not have words for. She predicted a question that would define our age. But what exactly did she understand that the greatest minds around her did not? By the end of this video, you'll understand why one Victorian woman's notes became the blueprint for everything you do online. Her name was Ada Lovelace. And her story was almost completely erased. Most people know her father, Lord Byron, the poet, the scandal, the man whose name became synonymous with genius and chaos and self-destruction. Ada's mother was terrified. Terrified that her daughter had inherited not just his name but his mind. The part of him that burned too bright. The part that broke things. So she made a choice. She would raise Ada to be the opposite of Byron. She filled her childhood with mathematics. With logic. With cold, clean numbers. Anything to suppress the imagination. Anything to kill the poetry in her blood. It didn't work the way her mother intended. By her teenage years, Ada was fluent in mathematics at a level that impressed the leading scholars of England. But she saw something they didn't. She saw that numbers and imagination were not enemies. They were the same language spoken in different dialects. In 1833, she met Charles Babbage. Babbage was a mathematician and an engineer who had become obsessed with an impossible idea. He wanted to build a machine that could calculate. Not approximate. Not guess. Actually calculate. Complex mathematical tables without human error. He called it the analytical engine. Nobody thought it would work. Most people didn't even understand what he was trying to build. Ada understood immediately. She saw Babbage's engine not as a calculator. She saw it as something else entirely. Something that didn't have a name yet. She began corresponding with him. She studied his blueprints. She learned every mechanical detail of his invention. Then in 1843, an Italian mathematician named Luigi Menabrea published an article about the analytical engine. It was technical. It was dense. It was incomplete. Someone needed to translate it into English. They asked Ada. What happened next changed everything. Ada didn't just translate Menabrea's article. She rewrote it. She expanded it. Her notes became 3 times longer than the original text. And in those notes, she included something no one had ever written before. A set of instructions. Step by step. For how to feed information into Babbage's engine so that it would produce a specific result. It was the first computer algorithm. But she went further. She wrote that such a machine could theoretically do much more than calculate numbers. She wrote that it might one day compose elaborate pieces of music. It might create graphics. It might process symbols and rules of any kind, not just mathematics. She wrote this in 1843. The first electronic computer would not be built for nearly 100 years. The internet did not exist. Artificial intelligence was not even a concept. Programming did not exist. And yet Ada Lovelace described all of it. She called her algorithm Note G. It was elegant. It was perfect. It showed an understanding of machine logic that would not be matched for generations. Then she stopped. She became ill. She was only 36 years old when she died. Tuberculosis. But by then she had already been largely forgotten. Babbage was the one people remembered. Babbage got the credit for the analytical engine, even though it was never finished. Ada's notes were filed away. They gathered dust in archives. Her work was unknown. Her insight was lost. For 100 years, almost nobody knew her name. In the 1950s, a mathematician named B.V. Asanoff was researching Babbage when she discovered Ada's notes. She read the algorithm. She understood its significance. She realized that Ada Lovelace had been writing about computing before computers existed. before anyone had the language to describe what she was doing. The rediscovery caused a sensation among computer scientists. Here was a woman who had intuited the entire conceptual foundation of programming. She had seen that machines could be instructed, that instructions could follow logical rules, that those rules could create something neither programmer nor machine could have predicted alone. She had described the essential mystery of artificial intelligence. Can a machine merely follow instructions? Or can it, through following those instructions, create something genuinely new? Can it truly think? Or only simulate thinking so perfectly that the difference becomes meaningless? These are not historical questions anymore. Today, 180 years after Ada's death, we live in a world where machines write prose. They compose music. They generate images. They predict patterns in data no human could see. And the question Ada raised in 1843 has become the central argument of our moment. Some say machines are only executing algorithms. They're doing nothing Ada's engine couldn't have done, just faster. They're simulators. Sophisticated parrots repeating patterns from their training. Others say that what happens inside these systems is qualitatively different. That complexity creates emergence. That following rules precisely can birth genuine creativity. That Ada was right. That machines can create. We don't have an answer yet. But Ada Lovelace had already identified the question. She had already articulated the problem that would haunt the 20th century and define the 21st. The woman who predicted artificial intelligence never lived to see it arrive. Her father wrote about love and darkness and the parts of human nature we cannot control. He burned bright and burned out. Ada did something different. She looked at a machine that didn't work. At a concept that didn't have a name. At a future that wouldn't arrive for a century. And she saw exactly what was coming.